All right, welcome back. This is going to be the next section of our AWS Machine Learning question and answer section. This is going to be questions 81 through 100. Before we get started, hit the like button, subscribe, share this with anyone you know taking the AWS Machine Learning Associate exam. So, question 81. A company has a binary classification model in production. An engineer needs to develop a new version of the model. The new model version must maximize correct predictions of positive labels and negative labels. The engineer must use a metric to recalibrate the model to meet these requirements. Which metric should the engineer use for model recalibration? Accuracy, precision, recall, AUC, ROC. A. So, accuracy measures overall correctness of predictions. You can see the formula there. This maximizes both positive and negative label predictions. The best metric when both classes are equally important, and it directly aligns with the requirement to maximize correct predictions for both labels. So the accuracy focuses on correct positive predictions and correct negative predictions, and both are weighted equally. Why are the other options wrong? So precision focuses only on positive predictions and ignores true negatives. Recall focuses only on catching all positives and ignores true negatives. AUC ROC is a model discrimination ability, not a direct measure of correct predictions. Next question, 82. Company wants to use machine learning to detect anomalies in network traffic patterns. The company has historical data labeled as normal or anomalous, but new types of attacks keep emerging. Which approach is most suitable? Supervised learning with binary classification, semi-supervised learning, unsupervised learning, reinforcement learning. B. Semi-supervised learning uses labeled normal data and learns the pattern. One class SVM learns what normal looks like. It can detect new unseen anomaly types. It doesn't require examples of all attack types. It adapts to emerging threats automatically, and it's ideal when normal patterns are consistent but anomalies vary. Semi-supervised trains on normal traffic, which is the majority of data. It identifies deviations as anomalies and it detects unknown attack types. Why the other options are wrong? Supervised binary requires examples of all anomaly types. It can't detect new attacks. Unsupervised clustering has no use of labeled historical data. And reinforcement learning is for sequential decision making, not anomaly detection. 83. An engineer is preparing data for model training. The dataset contains categorical variables with high cardinality. That means thousands of unique values. The engineer needs to encode these variables efficiently. Which technique is most appropriate? One-hot encoding, label encoding, target encoding, ordinal encoding. C. So target encoding replaces categories with mean of target variable. It handles high cardinality efficiently, so there's no dimension explosion. It captures relationships between category and target. It creates a single numerical column instead of thousands. It reduces memory usage and training time, and it's effective for tree-based models. So you can see an example here, the city target encodes to a single column with mean values versus a one-hot goes with 5,000 columns. That's a memory explosion. So why the other options are wrong? A one-hot creates thousands of columns. So this has memory and performance issues. Label has arbitrary integers and implies false ordering. An ordinal is only for ordered categories. 84, a company needs to deploy a model that processes sensitive customer data. The company must ensure that data scientists cannot access the raw inference data. What solution meets this security requirement? SageMaker endpoint with IAM policies, SageMaker with VPC endpoints and network isolation, deploy the model with SageMaker inference pipelines and data encryption, AWS private link with SageMaker endpoints. IAM policies. This provides the granular access control to inference data. It can restrict data scientists from invoking endpoint or accessing logs, separates permissions for model deployment versus data access, has the principle of least privilege, and CloudTrail can audit all access attempts. You can see an example of the IAM policy, which is deny SageMaker invoke endpoint for that particular resource from the principal who would do it. So why the other options are wrong? So VPC endpoint is network isolation. It doesn't restrict access. Encryption protects the data in rest and in transit, but doesn't restrict access. And private link is for network connectivity, not access control. 85. An engineer is training a neural network and notices the training loss decreases, but validation loss increases after epoch 15. What's happening and what should be done? Underfitting, overfitting, vanishing gradients, learning rate too high. So decrease the training loss plus increase the validation loss equals classic overfitting. So the model memorization the model is memorizing training data instead of learning patterns. This performs well on seen data and poorly on unseen data. Early stopping at epoch 15 would prevent overfitting. Regularization for L1, L2, or dropout would reduce overfitting. So you see the overfitting pattern, the training loss keeps decreasing, the validation loss increases after epoch 15. What's the solutions? Early stopping, adding dropout layers, L1 and L2 regularization, and reducing model complexity. Why are the other options wrong? So underfitting would mean both losses would be high. Vanishing gradients would mean that training losses would plateau or not decrease. Higher learning rate would see oscillating loss, not smooth decrease. Next question. 86. Company needs to identify items and images and provide their locations. The company will use SageMaker to create the model. Which service or feature will meet these requirements? Image classification, XGBoost, object detection, k-nearest neighbors. Answer is object detection. This identifies and locates objects in images. This provides bounding boxes with coordinates. SageMaker has built-in object detection algorithms. It returns both classification and spatial information, and a single model handles identification and localization. You can see an example of that object detection output, which show the class with the key value pairs, right? Class car, box, and it shows the coordinates, and then it shows the confidence score at 0.95 out of 100, or 1. And then why the other option's wrong. Image classification. This labels the entire image. There's no location data. XGBoost would be a gradient boosting for tabular data, not vision. And k-nearest neighbors would be a simple classification, not designed for vision with localization. 87. A company's data science team analyzes a data set to find defective product batches. The model produces an output of passed or failed. Robots separate the products into two categories by using the model to analyze photos on the assembly line. Which metrics should the company use to evaluate the model's performance? Choose two: precision and recall, root mean square error, and mean absolute percentage error, accuracy and F1 score, bilingual evaluation under study score, perplexity. A and C. So there's precision and recall. So this is a binary classification problem with the pass fail. The precision measures the false positive rate, which is incorrectly marking good as defective. Recall measures the false negative rate, missing defective products. It's critical for quality control scenarios, and both metrics need to understand the trade-offs. C, accuracy and F1 score. Accuracy shows the overall classification correctness. F1 score balances precision and recall. It's important when classes might be imbalanced, and standard metrics are for binary classification. Why are the other options incorrect? RMSC MAPE is for regression problems, not classification. Blue score is for natural language translation tasks. Perplexity is for language models. Question 88. A company's data science team analyzes a data set to find defective product batches. The model produces an output of passed or failed. Robots separate the products into two categories by using the model to analyze photos on the assembly line. What metrics does the company use to evaluate the model's performance? Choose two. We just did this. That's interesting. Sorry about that. So an engineer needs to encrypt all data in transit when an ML job runs. The engineer must ensure that encryption in transit is applied to processes that SageMaker uses during the training job. What solution will meet these requirements? Encrypt between nodes for batch processing, encrypt between nodes in a training cluster, specify a KMS key during creation of the training job, specify a KMS key during creation of the SageMaker domain. B. So inter-node encryption protects data in transit during distributed training. SageMaker supports TLS 1.2 encryption between training cluster nodes. You can enable this via the enable inter-container traffic encryption parameter. And it's required for compliance with encryption in transit mandates like HIPAA and FedRAMP. And it protects the model weights and gradients during training. So you can see how this would be configured with Python and TensorFlow. Why are the other options wrong? So batch processing is not specific to a training job encryption. And KMS keys are for data at rest encryption, not in transit. 90. Question 90. A company uses SageMaker for several projects. Each project has its own data and models. The company needs to isolate the projects from each other while allowing teams to share best practices. Which solution provides the best isolation? SageMaker, separate SageMaker domains, separate user profiles within a single SageMaker domain, IAM policies to restrict access within a domain, separate AWS accounts for each project. A, separate domains provide the strongest isolation boundary. Each domain has its own VPC, storage, and execution roles. There's complete separation of data and models. Teams can still share code or notebooks via Git. It prevents accidental cross-project access and supports multi-tenancy with security. This benefits include network isolation, storage isolation, IAM role separation, resource tagging per domain. So why are the other answers incorrect? So user profiles have the same domain and share the resources, so it's weaker isolation. IAM policies are complex to manage, and there's risks of misconfiguration. And separate accounts is over isolation, which is harder to share best practices. Question 91. Companies deploying models to a SageMaker endpoint. The models need to use accelerated computing instances. The company must ensure that each model can scale independently and that there are no cold starts. Which solution meets these requirements? SageMaker serverless, SageMaker asynchronous inference, SageMaker inference, create a SageMaker endpoint and an inference component. In the inference, specify the newly created endpoint, create an auto scaling for each inference endpoint, set the parameter for the minimum number of copies to be at least 1. Or create an S3, store all the artifacts in S3. Create a SageMaker multi-model endpoint. Point the endpoint to the S3, create an auto-scaling policy for the endpoint, set the parameter for the minimum number of copies to be at least 1. C. The inference components support accelerated instances, so GPUs, and individual scaling policies per model. The minimum copies prevents cold starts. There's real-time inference support, and each model can scale independently. This is optimized for GPU workloads. So you can see the inference components architecture has an endpoint with component 1, 2, and 3, the auto scale set for the minimum 1. Why are the other answers wrong? Serverless has cold starts. It doesn't support accelerated instances. Asynchronous, not for real-time responses. And multi-model is wrong because it shares resources. There's potential cold starts, and there's no individual scaling. 92. A company uses SageMaker for its ML process. A compliance audit discovers that Amazon S3 bucket for training uses server-side encryption with S3 managed keys. The company requires customer managed keys. An engineer changes the bucket to use server-side encryption with KMS keys, SSE KMS, and the engineer makes no other configuration changes. After the change to the encryption settings, SageMaker training jobs start to fail with access denied errors. What should the engineer do to resolve the problem? Update the IAM policy that's attached to the execution role for the training jobs. Include list bucket and get object. Update the S3 bucket that's attached to the S3. Set the value of the AWS secure transport condition key to true. Update the IAM policy that's attached to the execution role for the training jobs. Include KMS encrypt and KMS decrypt permission. Update the IAM policy that's attached to the user that created the training jobs. Include the KMS create grant permission. C. So SSE KMS requires KMS permissions to decrypt data. SageMaker execution roles need KMS decrypt to read the encrypted training data, and also needs KMS encrypt for output artifacts. Without KMS permissions, you'll get access denied on encrypted S3 objects. So S3 permissions alone are not sufficient with KMS encryption. So you can see the JSON with the required permissions with KMS decrypt, encrypt, and generate data key for the KMS key yarn. Why are the other options wrong? So S3 permissions only. This already has S3 access, but it's missing KMS permissions. Secure transport. This is for data in transit for HTTPS enforcement. It doesn't grant KMS access. User permissions. The training job uses execution roles, not user permissions. Question 93. The company needs to run machine learning model training jobs on SageMaker for 5 hours a week over the next 55 weeks. The company wants to reduce model training costs. What solution will meet this requirement? What are the options? Use a serverless endpoint with a provision concurrency. Use SageMaker Edge Manager for the training. Specify the instance requirement. Use heterogeneous cluster feature of SageMaker training. Configure the instance type, instance count, instance groups. Opt into a SageMaker savings plan with 1 year term and an all upfront payment. The answer is D. So for predictable, consistent workloads, this is what you need. For 35 hours a week, for 55 weeks, that meets that 1 year standard. SageMaker Savings Plan offers up to 64% discount versus on demand. The 1 year term covers that 55-week requirement. All upfront payment maximizes the discount. It's purpose built for cost optimization on steady workloads. So you see the difference in cost comparison between on demand, savings plan, and savings are about 3,500. Why are the other options wrong? So the serverless endpoint is wrong because this is for inference, not training. The Edge Manager is for edge device deployment, not cloud training. The heterogeneous clusters is for performance optimization, not cost reduction. 94. A company needs to train an ML model that will use historical transaction data to predict customer behavior. The engineer must select AWS services to perform specific tasks. Which AWS service must be used for each task? Choose 3. Each service is used once. Available services include Athena, Glue, Kinesis Data Streams, and S3. So task would be store historical transaction data, transform and prepare data for training, and query and analyze historical data. Oh, I think I forgot the images for this. Let's see. Okay. Yeah. So S3 would, yeah. So you're supposed to map this to this. Okay. That's what makes sense. You're supposed to map this. So yeah. So the historical data would be S3, transforming it would, ETL would be Glue, querying would be Athena. Yeah. So you see that S3, object storage for data lakes, cost-effective storage, supports CSV and Parquet and JSON. It's foundational. It's a foundation for data pipelines. Glue is the ETL, serverless ETL service, built-in transformations, handles data cleaning and feature engineering, and integrates with SageMaker. And Athena is your serverless SQL queries on S3. There's no infra to manage, and it's pay per query for exploratory data analysis. Kinesis is not used just because you don't need real-time streaming data. So there's no need for historical batch data. Or it's not needed for that. 95. Company deployed a model that uses XGBoost algorithm to predict product failures. The model is hosted on a SageMaker endpoint and is trained on normal operating data. A Lambda function provides the predictions to the company's application. The model's predictions are becoming less accurate over time. The engineer discovers that the distributions of recent data and training data have diverged significantly. What should the engineer do to improve the model's accuracy? Enable automatic model retraining, retrain the model with recent data, increase the endpoint instance size, enable SageMaker model monitor for data quality checks. B, so the data distribution has changed. That's data drift is detected. So the model was trained on old distribution and performs poorly on new data. So retraining with recent data will capture new patterns. And this would include new failure modes and operating conditions and address the root cause of accuracy decline. So the retraining process would include collecting the recent data with the new distribution, label the failures in recent data, retrain the model on updated data sets, validate on held out recent data, and deploy the updated model. Why are the other options incorrect? Automatic retraining, well, you need to define the retraining strategy first. Large instances, this doesn't address the data distribution change. It would just do it faster. Model monitor would detect drift, but not fix the accuracy problem. 96. The company is using SageMaker to build and deploy ML models. The company needs to track which data set version was used to train each model for audit purposes. Which solution would meet this requirement with least operational overhead? SageMaker experiments to track dataset versions. SageMaker ML lineage tracking to automatically capture dataset model relationships. Store dataset versions in S3 with metadata tags. Use CloudTrail to log all training job parameters. B, so lineage tracking automatically captures dataset to model relationships. There's no manual tracking required. It's built in the SageMaker workflow. It creates queryable lineage graphs. It tracks complete audit trails from data to deployed model. It's purpose-built for ML governance and compliance. It's the least operational overhead and allows automatic capture. So you see the tracking capabilities include dataset version of the training job to the model artifacts, the model to the endpoint deployment, and complete reproducibility chain. Why are the other options wrong? So experiments manual requires manual tracking. That's higher overhead. S3 metadata is a manual process. There's no automatic model linkage. And CloudTrail logs API calls, doesn't create dataset model relationships. 97. An engineer is deploying a real-time inference endpoint that will receive unpredictable traffic spikes. The endpoint must scale quickly to handle demand while minimizing costs during low traffic periods. Which strategy should be implemented? Use scheduled scaling, use target tracking scaling, use step scaling, manually adjust instance count. Mm. B. Target tracking automatically adjusts capacity to maintain target metrics. And invocations per instance directly reflects actual load. It responds to unpredictable spikes automatically, scales up and down based on the real-time demand, and it minimizes loss or costs by scaling down during low traffic. And there's no manual intervention required. So you can see a configuration with some Python's scripting showing the endpoint, the tracking policy, the target value, and the predefined metrics. Why are the other actions wrong? Scheduled can't handle the unpredictable spikes. Step scaling is more complex to configure than target tracking. And manual is another high operational overhead and slow to respond to spikes. 98. Companies train an image classification model that achieves 95% accuracy on the test set. However, the model performs poorly on images from a specific camera manufacturer. What is the most likely cause and solution? Underfitting, data bias, overfitting, feature engineering. B. So training data lacks representation from a specific camera manufacturer. The model hasn't learned patterns specific to that camera. Data bias means that the training set doesn't reflect the production diversity. So a solution would be include more samples from the problematic camera in training. And this will ensure the model learns to handle all camera types. So the data bias pattern would show training cameras A, B, and C are well represented. In production, cameras A, B, C, and D, but camera D is missing from the training. So the result would be poor performance on camera D. So why are the other options wrong? Underfitting. Well, the model achieves 95% overall. It's not underfitting. Overfitting would affect all test data, not specific cameras. And the feature engineering, the features work for 95% of cases. Question 99. An engineer needs to perform a hyperparameter tuning for deep learning models. The training takes 6 hours per job. The engineer has a limited budget and needs to find optimal hyperparameters efficiently. Which tuning strategy will minimize costs? Grid search across all hyperparameters, random search with 100 trials, Bayesian optimization with early stopping, manual tuning. Bayesian optimization learns from previous trials. It focuses search on promising regions of hyperparameter space. There's early stopping that terminates poor performing jobs. It minimizes wasted compute on bad configurations. It's most efficient for expensive training jobs, so 6 hours or more. This typically finds good parameters in 20 to 30 trials versus 100 plus for random. So you can see the cost comparison. The grid search would be 100 combinations, would be 6 hours, or 600 hours, excuse me. Random would be 100 trials, would be 600 hours. Bayesian would be 25 trials, would be 150 hours. That means a 75% savings. Why are the other options wrong? So grid search tries everything. It's exhaustive, it's most expensive. Random search, you're gonna waste a lot of trials on poor configurations. So manual is too inefficient. There's no way of guaranteeing a finding for an optimum method. Question 100. Company needs to ensure training jobs run in network isolation without internet access. The training data and model artifacts are stored in S3. What configuration meets these requirements? So, enable network isolation in training, use NAT gateway for S3. Network isolation, create VPC endpoints for S3 and use S3 gateway endpoint. Training in a public subnet with a security group blocking the internet. Private link to access S3 from training instances. B. So, network isolation mode prevents all internet access. VPC with the S3 gateway endpoint provides private S3 connectivity. There's no internet gateway or NAT required. Traffic stays within AWS. It meets compliance requirements for FedRAMP or HIPAA, and data never traverses the public internet. So you can see the architecture would be a training job to the endpoint to the S3. Why are the other options wrong? So NAT gateway, so the NAT provides internet access. That violates the isolation requirement. A public subnet, well, it's not truly network isolation. And private link So S3 uses gateway endpoints, not private link. So that will be all for this one. Before we go, hit the like button, subscribe, or share with anyone you know taking the AWS Machine Learning Associate exam. Thank you, and have a good day.